didn't get to really connect all the pieces tomorrow. Yesterday, because of the fire drill, we got a little bit there, but not totally. Because factoring wasn't the point. Factoring was just a tool that we're going to have to use. Now, 1 and 2 and 3 and 4, we liked number 3 on the worksheet, right? Because number 3 was already factored. So let's go do number 3. Let's ignore 1 and 2 and 4 for a second. Let's go do number 3, and then we'll come back to 1 and 2 and 4. Because number 3 is great. He's already factored. He's already nice and neat and ready to go. We're going to go to number 3, and then we're going to come back to 1 and 2 and 4, reading the directions, trying to figure out what they're asking of us, etc. And trying to fill in some of the clues. Okay? So, number 3. Oh, actually, did all of you guys get this written down from yesterday? Was anyone still writing in their notes and we ran out of time? We were okay? Okay. I'll make sure that I put up both of these pages on the screen in just a little bit. Some of you are writing notes on your worksheet itself. Some of you are writing notes in your notebook. That's what I would probably recommend. So you have the practice problems on your worksheet and you have the notes in your notebooks. But we're going to go peek at number 3, because number 3 is a little different than all the rest. But I'm going to keep this page up from our notes because it kind of helps us remember what we're doing. Let's see. Let's do this. I did this in a way yesterday that I think was good and it wasn't bad. I was reminding you that if we can get it in this nice factor form, like number 3 has, if we can get it in this nice factor form, like number 3 has, we can quickly fill in our x-intercepts of P0 and Q0. This is actually from 8.5a practice page, or 8.5a notes. If you guys want to look at that. Then we have that nifty formula for the axis of symmetry, which is P plus Q all divided by 2. But then it gets kind of tricky because I yesterday went ahead and wrote the same thing up here in the X spot. But for some of you, that just gets to be a little bit messy. So I'm going to go ahead and call this H. Because back in vertex form, we had an H and we had a K. Y equals A times X minus H squared plus K. And we called the X of the vertex H. And we called the Y of the vertex K. So I'm going to go ahead and call this guy H, because that's who he is. So I can go ahead and say, hey, just plug in. Remember, these two match. A lot of you did really good on that in your last quiz. And then I can put in that H into my function, f of H. So maybe that makes that a little bit nicer and neater. I think it looked kind of gross yesterday when I was writing this like 1, 2, 3 times. That was kind of hard. I think I like it better with the H. Can anyone remind me real quick, just to finish this off from yesterday, we didn't remind ourselves of these 2 blanks. What's the domain of any, you guys already got it, all real numbers, right? And there's that nice little shortcut way of writing it, but I can go ahead and also say all real numbers. Domain is all real numbers. But what about the range? Okay, either, good. Either y is greater than or equal to h, or yeah, and it's all dependent on whether greater than or equal to or less than or equal to. It's all dependent on the shape. So which way would my parabola be facing, up or down, such that the y's are always greater than the vertex? Good. So that if you want, you can do an upwards parabola here. Okay, reminder. And then which way would y be staying under h? Got it. Okay. Whew. So that's like all the characteristics of all the graphs. Kind of like 8.5a and 8.5b, the beginning. But what's going on in the directions in number 3? We really liked number 3 because he was already factored. We had absolutely no factoring work to do. But what are the directions saying?
Graph the function.
Using what?
0.
Okay, so pause. Zeros. What's 0? I don't know. A number. But what are the zeros of a function? Or what are the zeros of a graph? Ready? It's super important that you guys realize that anytime you have heard the word or the, what would you call this? 1 word? 2 words? A hyphenated word? Anytime you would see x-intercepts, you can think the word zeros. And anytime you hear the word zeros, you can think the word x-intercepts. So, can I have you guys do something on your practice page? Can you, in the directions, circle the word zeros And can you remind yourself that those are just x-intercepts? Can you guys circle the word zeros? Find your practice page from yesterday. Find your practice. Melanie was gone yesterday. Sky was gone yesterday. Andrew, you were gone, but you came back. Good. Did you guys already circle the word zeros and write x-intercepts? So what's really cool on number 3? What can we do right away because it's written in the factored form? Isaiah.
Well, we go back to the trace. Are we using the x-intercept features or using the original equation?
The x-intercepts which come from the original equation, as long as you remember signs back. Does that make sense? So in this one, Isaiah's already going down to the vertex because the vertex is super helpful with graphing, so we're going to do that in a second. But the problem is, guys, is this written in a really nice vertex form where we can steal the h and steal the k? Is it written like this? Compare. Is this vertex form? Or is this intercept form? Yeah, intercept form. So vertex form, we could steal the h and steal the k, but we don't have that. We have intercept form, which is okay. We're just not going to jump straight. I know Isaiah's thinking ahead. We're not going to jump straight to the vertex. We're actually going to go straight to the x-intercepts. So you guys already circled the word zeros. You wrote x-intercepts, so let's fill in x-intercepts. What are the x-intercepts, guys? -1, good trend. It's backwards. 0 and 3, 0. Wait, pause, guys. Did we factor number 4 yesterday? Oh, maybe not. I see some of you guys that didn't factor number 4. Okay, never mind. I was going to have you go try number 4, but we haven't factored him yet, so we can't pull these. Check it. If it's not written in the factored form, this one's easy. That one's not. That's why we have to remember factor. If it's written in factored form, pull it, pull it. It's right there. If it's not written in factored form, that's why factoring is so important, because factoring lets us go to the easier form, and then we can pull clues out. Now, you guys, hold on. You remember this. If you have 2 points, get it on the graph. If you're -1, 0 on the graph, you're going left 1, right? If you're 3, 0 on the graph, you're going right 3, right?
Right.
But we need 3 points. So Jerry and Danny, we good? Danny, hood off, please. If we have our intercepts, Isaiah, why were you thinking about the vertex?
Oh, I was looking at the other column and trying to do it myself, and then I got stuck on number 2.
Got it. So you were trying to think to filling in the vertex. Yeah. So we're going to go ahead and help him with his number 2 vertex question by finishing off number 3. If we have -1, 0 as a point, oh, that's way off. Sorry, guys. If we have 3, 0 as a point, these are intercepts. Can we tell just by looking at this guy whether it's going to be a concave up or a concave down?
Yes.
How, Jerry?
It's greater or less.
Okay, greater or less than is our hint, right? But that's for the y's. What's going on in the equation that tells us?
Negative and positive.
Good. So is this a positive guy or a negative guy? Look at yours, because mine's kind of funny looking. It's y equals, guys, what's right after the y equals? A positive or a negative before the parenthesis? It's an understood positive because there's nothing there. Does that make sense? So it's an understood positive. What's this guy? Oh, also positive. They're both concave up. So we know it's concave up. Oh, we could almost swoop if only we had the... Oh. But as Isaiah was having us review just a second ago, we can find the vertex with the little baby formula. What's the little baby formula say to do?
X equals 2 plus q over 2.
So, -1 plus 3, divide by 2. PEMDAS. I have to add first. Careful. Go step by step, because what's positive 2 over positive 2?
1.
Well, stink. Hold on. I know where it's at. I know it's at x equals 1, but the problem is, guys, that's only the x of the vertex. How do I find the y?
Plug it into the equation.
Now the plug it in. So, take a second. I want you to plug into the equation and do legal PEMDAS. I need you guys to figure out when x is 1, my vertex has a y, but what is it? I won't know until I plug it in, plug it in. If you want, you can do f of 1 to use our snazzy notation. Some of you might like to think of this as an f of x. Plug it in, and do PEMDAS. Plug it in, and do PEMDAS. And actually, the PEMDAS might be easier to this one. I'm running out of room. I'm going to do this down below. You guys plug in 1 plus 1 and 1 minus 3. What would PEMDAS have me do first?
1 plus 1.
Good, which is?
2.
What's the operation when parentheses are next to each other? Good. And what's 1 minus 3? Negative 2. So what's 2 times negative 2? Am I done?
Yes.
Basically. So all I have to do is graph my vertex and swoop, there it is. So I'm going to graph my vertex at 1 Everest. I see that hand. Give me 1 second, I'm coming. I need you guys to help me out with the steps that I took to get this answer. Sadly, my orientation is a little bit off, so it's a little bit wonky. But if we were supposed to be using the zeros to graph the function, which is exactly what the directions give us, what was the very first thing? 1, 2, 3, and 4. Okay. What was the very first thing I had you guys write down once we realized zeros were just x-intercepts? What was the very first thing I had you write down?
X-intercept.
Uh-huh. And where did I get these from? Uh-huh. I could just take the opposite sign, stole from the equation. Trey totally was like busting it out. And we just had to make sure those signs were backwards. Once we had the x-intercepts, Isaiah, what did we do next? Found the axis of symmetry, and the axis of symmetry gives us the same, or is the same thing as the x of the vertex. So we found the axis of symmetry. It gave us the x of the vertex, and then last but not least, everyone, what did we do with that x? Plugged it in to find the y, and then we had our vertex. Now, guys, can we all admit number 4 is a little bit harder?
Yeah.
Because he's not factored. I love that you knew that word. Like, that's perfect. That's Alg1. That's Alg1B specifically. He's not factored. He needs to be, and we'll get back to that. But to be honest, for right now, let's go back to numbers 1 and 2 yesterday that we did factor. I think we did. Double check. Did you guys get the factoring of both 1 and 2? Did you get the factoring of both 1 and 2? Number 1, we pulled out our GCF, remember? And number 2, whether you use the X table method or whether you use the guess and chess method, what factors of 7 make 8? Will positive 7 and positive 1 do? I'm curious as to what you guys can fill in. Because what we just did a second ago was, hey, what are the x-intercepts? Okay, what is the axis of symmetry? Okay, what is the vertex? We just practiced that in number 3. Can you use this now? Okay, this one is proper, but it doesn't show as much as this one. It doesn't show as much as this one. So we have our hints, we have our tricks, and we have our sample problems. I think yesterday we started solving this one. We just might not have finished the entire thing. Did you guys get written down for number 2, and I'm going to have you try number 1 on your own. Did you write down for x-intercepts negative 7, 0, and negative 1, 0? Did you get that on number 2? Good question. Where did I get it from? X-intercepts always come directly from up above. So, not here, but did you factor it? There's the negative 1, there's the negative 7. You see it? Signs are backwards. Now, as soon as we have the negative 1 and as soon as we have the negative 7, remember, I am grading these worksheets tomorrow in class, and I want you to have 100. Andreas, do you have the worksheet? Here, I have an extra coming back to answer Ever's question. Here you go. Oh, she have 100 on it, yeah? Okay. So right now we're on number 2. Do you have it written as factors? Yeah, you do. Now, from these factors, take these numbers. Yeah.
Someone else did not care about their water, like what they have this water.
Is the seal not broken?
No.
Go. If you come in looking, I'll be like, well, sorry. Oh, that's a nice water. Question. Was anybody else able to fill in any other blanks? We wrote down the x-intercepts, so now what? Axis of symmetry. But pause. Let's solidify this. Can you guys write down the x-intercepts for number 1? We have that factor 2. If you wrote down the x-intercepts, it seems like we're getting a little bit lost. So go to number 1. Fill in those x-intercepts. If you've written it in factored form, or look at my factored form, I made it x minus 0 to be easier on my head, because my head likes seeing x plus or minus for 2 different factors. So even though this one doesn't have a plus or minus, I'm like, oh, it's a 0. So what do you guys fill in? What's one of the x-intercepts? Jerry, I'm sorry. Yeah, whenever it's these printed ones, it's on the worksheet. Yeah, that was the first thing you were supposed to get out. It's all right. Now you can save time. Good job following along, though. What'd you guys get as one of your intercepts? 0, 0. Okay, hold on. Are we okay? Are we okay? The intercepts come straight out of the factors. Just signs backwards. So we stole straight out of the factors. -7, -1. We're stealing straight out of the factors. So 0, 0, and what's the other one? 8. Okay, all right. So we're okay. Yeah, on the intercepts? Yeah. Cool. Now, Trey told us now we need the axis of symmetry, and Isaiah reminded us there's a formula for that. Okay, so here's our formula. If you need to, you can get a little highlighter. You can highlight it in your notes, or you can write it right now on your worksheet right next to axis of symmetry. Well, hold on. It's easy to start. It's x equals. I know that. Vertex is a point. I could do my parentheses with a comma like we set it up before. Axis of symmetry is an x equals. But to fill in either one of these, I need this formula, and that's where the word average came in. Because average says add the 2, divide by 2. So, which one looks easier to add the 2, divide by 2? Number 1 or number 2? Sure. So number 1, if we add P and Q, what do we get? 0 plus 8, and then all over 2. Okay, so PEMDAS, I need to do 0 plus 8 all over 2. If you guys are getting this one, then rock it, finish it, and go to number 2 and get that one done too. But PEMDAS would tell me 0 plus 8 is what? 8. And what's 8 over 2?
4.
I can put a 4 in my vertex, and I can say that 4 is my axis of symmetry. Okay. Yeah. Because I need my y, yeah? So I'm going to go ahead and he's tracking f of 4. Plug it in. Jerry, finish it. Make sure you're right. And then do number 2. Finish that one. You're solidifying it and having it ready to ace homework tonight. So we plugged in the p plus q over 2. We got 4. Hey, that's the x of the vertex. Hey, it's an x. Let's plug it in and get a y. And technically, you can plug it into here, or here, or here, whatever form you like. As long as it's one of the equations, you can plug in. But are you guys practicing the axis of symmetry over here too? What's p plus q over here in number 2? What's -7 plus -1 all over 2? -8 over 2. And what's -8 over 2? -4. So this one we're going to be plugging in negative 4. Now guys, one more time, you can be plugging into whatever form you want. You can be plugging into the top equation if you like that one, or the secondary factored form. That's okay, it's still the same thing, it's just in a different form. You can be plugging into the top, oops, you can be plugging into the bottom, there you go. They're all the same thing, it's just different forms. They're all the same thing, just different forms. So you can plug into whichever one you want. So real quick, whole class, what are we supposed to be doing right now? Plug it in, good Jeremy. What are we supposed to be doing right now? Plugging it in. Now we have like 3 people. What are we supposed to be doing right now? Plug it in what? That's the vertex, right? To get the y of the vertex. But yeah, plug in 4 to the first and negative 4 to the second. And as soon as you have, oh, rocking it, I'm guessing. How does Andrew Bosch already have graphs on 1 and 2? Do you have graphs on 1 and 2?
Yeah.
If you have your 2 intercepts and a vertex, if you finish plugging in, should you have your parabola?
Yeah.
If you have your 2 intercepts and your vertex, if you finish plugging in, should you have a parabola? Yeah, you should. But don't worry, I'm going to catch up with you guys. You guys keep plugging in. I'm going to orient my screen because it's starting to be a little bit imprecise. I'm going to zoom in on the graphs because I have a few of you that are squinting trying to see what we're doing. It was zoomed out so you could see the formulas and you could see the patterns. The little reminders that we have put in notes. But let's go ahead and try to get it where we can all see a little bit better. Huh? There we go. Alright, so you guys are plugging in. When you plug in 4, I don't know about you guys, but I think I would rather plug it into this one than that one. Maybe it doesn't make a difference to you. I think I like this one because it looks easier. Minusing by 8, timesing by 2. I don't want to do 16 times something. So I'm going to plug it in 2. 2 times 4 times 4 minus 8. But once again, you should get the exact same answer if you plugged it into the top form or the original form. Kind of like if you were to give a burger to Batman or give a burger to Bruce Wayne. Aren't you doing it to this? It's the same thing. No, but they're 2 different. No, it's the same person. Kind of like that. You're plugging into one of those forms. They might look differently, but they're the same equation. So it's okay. Penja says parentheses. And then I need to multiply left to right, right? So 2 times 4 is
8.
And 8 times, careful.
Negative 32. I got that. I got it right.
Oh, struggle! How are we supposed to put this on this graph in a way that it fits?
Put in the bottom.
How? What if we go by 4s? Or we could have, this is negative 10, we could pretend negative 32, and then we could draw a big, huge parabola. That's going to be a mess, though. I think we should go by 4s. Is that okay? So if we go by 4s, let's see, this would be 40. This would be negative 40. Okay, that'll fit, because 10 times 4. That'll be 40. This will be negative 40. So I'm going to have 0, 0, and 4, 8. Oh, man, this is going to be squished. Because 8's just like 2 blanks away, right? So I have 0, 0, and then 4, and then 8. 8, 0. And then 4 is the halfway in between point, and 4, well, he's going to go down negative 4, negative 8, negative 12, negative 16, negative 20, negative 24, negative 28, negative 32. It's going to correspond to negative 8. Negative 8 times 4. So it's kind of awkward. We have to go by 4s instead of going by 1s, but we got it. Those of you guys that graphed your parabolas, double check, because you might have plugged in a little off if your parabola fit nice and neat. Because this one, negative 32, dang, that went low. But the nice thing is, guys, domain, what can I fill in right away?
All real numbers.
Yeah. Hey, do that for number 2, too. You know that one. Go fill it in, all real numbers. So what about range? It's a y. We knew that, right? Y greater than or less than? Greater than, because it's above. Greater than or equal to who or what? What's the lowest the parabola goes? Negative 32. Rocking it. So then did you plug into the second one? Now, you guys get to choose for me. Are you going to make me plug into the top one? Or do you get to plug into the factored one? Factored? Right? It looks so much easier. Okay, cool. I'm going to plug it into that one. So I'm going to plug into, let's see, plus 7 plus 1. I need to take my x, which is negative 4 plus 7, and my x, which is negative 4 plus 1. We're just plugging in to find our vertex. Yeah, good. PEMDAS. PEMDAS is a negative. This one's a negative. This one's a positive, though, right? What's negative 4 plus 7? 3. And what's negative 4 plus 1? And what's 3 times negative 3? Oh, times, no. Negative 9. Does this one fit on my graph nice and... Oh, yeah. So I got my negative 7, 0. I got my negative 1, 0. Negative 4 needs to go down to negative 9. There it is. You guys should have already filled in your domain is all real numbers because it always is. How about my range? Greater than or equal to or less than? Less than? Means below. Greater, oh, this is good to write in your notes. Less than means below. Does the parabola go below this? Or does it go above? Yeah, it goes above. And how low was that? Negative 9, right? Whew. So those of you guys that are writing in notes, or those of you guys that have your notes open, you're trying to just give yourselves little reminders. Check it. Do you see how over here, greater than or equal to went with the concave up always because I'm going up or above? Less than or equal to goes with the concave down because I'm always going below. So here's something crazy. I think I made a mistake because, guys, we're not stealing the x for the range. What are we talking about? Not the x, not the h. We're stealing the y value. Or the k. And the k, remember, he can also come from plugging in, which is what you guys just did. It worked perfectly, and we were able to finish 1 and 2. We have number 3 done. We're so close to finishing off this worksheet. Who's that little guy that's kind of hanging over our head and is still mostly blank? Number 4. Why is number 4 still blank for almost all of us? It's not factored. These other ones, we worked hard at the beginning of, well, after the fire drill. We worked hard at factoring 1 and 2, and once it was factored, it was easy. Number 3 was already factored. Number 3, stop staring, you're distracting. Number 3 was already factored, and so that was easy. Number 4 is not factored, so it's not easy. Let's see. So I'm going to go ahead and zoom in on number 4 because we have to figure out how to factor him. And actually, I'm going to add a page just for factoring. Help me out, guys. I already have this factored in my head. So you don't want to hear me do it because I'm just going to go straight to the answer. I mean, you probably do, but you need to do some factoring tonight.
I got it.
Oh, we already have him?
Yeah.
Jonathan, what do you think it is?
X minus 3 and X minus 7.
Pause. How can you double check that he's right? Is it going to give me, if you guys are table people, is X minus 3 and X minus 7, is it going to give me an X squared? Yes. X and X always gives X squared. Is it going to give me a positive 21?
Yes.
Yes, a negative times a negative is a positive. Yes. And what's going to happen with the negative 7x and negative 3x?
10.
Nice. But if your brain doesn't go straight to an answer, remember, you could have put the 21 in the top of the x with the negative 10 and asked yourself, what factors? Oh, 3 and 7. Oh, negative 3. Negative 7. And then you could have come over to your table and then factored and gotten the exact same thing. But what's nice, what can we do now that we have the factors? Yeah. Because the zeros, they're just the x-intercepts. And don't you get the x-intercepts by just stealing from the factors? Yeah. Sweet. So what are my 2 x-intercepts?
Positive 3.
Positive. Wait, positive what?
3.
Good. Careful. Yeah. But put that 0, right? Because they're points. And then positive 7. Great. Graph our intercepts. We already have 2 points. All we need is the vertex. Let's see if you guys remember how to find the vertex. If you have the 2 zeros, aka x-intercepts, aka 0, aka x-intercepts. Get some more. Get some more show. You're gonna get stuck in homework. Did you know where to go next? Did you graph them? Hopefully that's the first part. 3, 4, 5, 6, 7. But did you go? No. Did you know where to go? Did you know where to go next?
Yes.
Okay, what'd you do, Jonathan?
It's 3 plus 7.
Good. All divided by?
2.
What'd you end up getting?
5.
Perfect. Now, 5 is part of the vertex. What else do I need? Plug it in. I have my vertex. I have the 5. All I need is the y. And to get it, what do you guys want to plug it into? What do you think? Make it easy on yourself. The top or the bottom?
Bottom.
I like the bottom. But if you like the top, it's okay. You'll get the same answer. I like the bottom. Sorry, it's over here. I like this guy because he looks so much easier. But you could plug it into either one. I'm going to plug it into the bottom, the factored form. It's 5 minus 3 times 5 minus 7. Is that right? Yeah. 5 minus 3, plugging in, and 5 minus... You could have plugged it in here.
2 times negative 2.
Good. 2 times negative 2. Jerry's already telling us what it becomes. It's going to become...
4.
Dun, 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 dun. 1, 2, 3, and 4, and school. I don't mind graphing by zeros as long as I can factor. If I can't factor, it's like... which is why we had to review factoring. If you guys remember, factoring got really hard when there was a number in front. And we had to multiply a times c modified x method. Got really hard when there was a number in front. But look at 1 and 2 and 3 and 4. Are there any numbers in front of the x squares?
No.
In front of the x squares? No, which is nice because in homework, guess what? They're giving you the easier factoring problems. They're not giving you the harder ones with the numbers in front. Not yet. So, in homework, the one that's up there, 13, 15, 17, 38, and 40. It's going to look very similar to our worksheet where you are trying to identify all the key characteristics of a graph like vertex, axis of symmetry, x-intercepts, domain, and range. Like 1 and 2, wherever they are. Where's 1 and 2? Oh, here they are. 3 and 4, all we got to do is get our zeros, our vertex, and swoop, there he is. Now, this one is the one that was due today on RenWeb, but the fire drill slowed us down, right? This one was the one that was due today on RenWeb, but the fire drill slowed us down. So the nice thing is, I'm not going to be checking section 8.5 until tomorrow. But can you remind me, hold on really quickly, everyone paying attention. Why am I checking 4 things tomorrow? If this is the homework, that's one thing. Why am I checking 4? Because we have the 2 worksheets. And if you've done them with us in class, that's 100%, right? And the 2 homeworks. Booyah. I'm checking all of 8.5 tomorrow. Now, if you guys notice, we still have about 10 minutes left of class. Now, we're technically behind because of the fire drill. It makes sense, right? We're out in the field just chilling. And they're important because we never know when something's going to happen, and then we want to know what to do. However, I do not want to confuse you, so I'm not going to give you a whole new practice page today. I'm just going to wait to give you, do you see what section this is? We're going from 8.5 to 9.5. Yes. The next test is going to be on 8.4, we already did, 8.5, the one in front of you, and 9.2. That's it, 3 sections, 8.4, 8.5, 9.2.
What's the test?
Next week? On RenWeb. I think it might have gotten bumped today, though, because of the fire drill, so it's a day later than I thought. But it's next week, probably like next Wednesday-ish. But we only need to get through one more section. 9.2. Now I'm not gonna give you more practice pages today. Once again, I don't want to confuse you. 4 things for tomorrow. After we're done. However, I do want to show you what's coming in section 9.2. Wait a minute. Look at the title of 9.2. Does that look really strange and weird and different? Solving quadratics using what? And what are we even doing in 8.4 and 8.5 with quadratics?
Graphing.
So we're just using what we've done. Do you see what at the last section before our test? We've been graphing. So now we just have to, oh, yay. Okay, here's what I want you to do. I want you to turn in the back of your homework spirals. Turn in the very back of your homework spirals. We could go to section 9.2, but if you just notice, section 9.2 is really just using what we've already done. It's not meant to be super hard or crazy. So instead of us going to section 9.2, which we could do, I'm not sure it's super helpful. I'm actually a little more worried. Maybe worried isn't the right word. I think what would be more helpful for you guys in homework tonight is to practice factoring. Ready? I want one person from every single group to come on up and grab a little baby whiteboard, a tissue, and a marker. Go. Right here. We're going to work together. I don't want you working alone. That's not a good idea. But some of you are sleepy, some of you are tired, some of you are out of it. Hold on, don't grab those markers. Those markers are bad. Come grab these markers. Those markers are bad. Come grab these markers. So maybe now double check that your marker writes well. Double check that your marker writes well. Andrew, Everett's in the restroom right now. I'm gonna have if we're almost done class. Can you come sit next to Kayla? They're gonna be in there. Alright. You don't even need to write anything down unless something is like, oh, I think I should use that in homework, or I think that'd be helpful to write down. Otherwise, the only writing down is going to be on your little baby whiteboard with a marker and a tissue. Now, you guys remember from before, only one person is allowed to be using writing with the marker, but everyone else can be giving ideas or giving corrections or saying, oh, don't do that, I think it's this. Now listen carefully. I'm going to go ahead and give points. Do you guys see that Calculus AB had a competition today too? I'm going to go ahead and give points based on whether or not you got it right the first time. Now if you get it wrong, I'll let you try again, but it won't be for any points. Now, if you want to submit an answer, if you're like, nah, we got it, we know it's right, then all you need to do is just hold it up and I'll come check it. Okay? I'm going to give a few different problems. I'm going to put down, I think, like 4 different factoring problems. Only one person is allowed to work on or use the marker on one problem. As soon as your group finishes one of them, pass the marker, pass the whiteboard, you can go to number 2. The first group to get to number 4 first wins. But you have to get there correctly. Okay? Actually, let's forget the whole points thing altogether. We'll just say the first group to get to number 4 and to finish it wins. So hold on. Whoever has the marker right now, you only get to do one problem, then you have to pass it off. Nobody can do more than one. Okay? But everybody can weigh in, everybody can give advice, and if I were you, I would double check before grading with me. Because if you get it wrong, I'm going to walk away and you have to try again. That wastes time. Here we go. All of you start on number 1, start working, and then I will have 2, 3, and 4 up here waiting on the board for you. Number 1 is x squared plus 8x plus 15. Go and start working on that. I'm going to put the other ones up here.
What?
Yeah, you can go sit with Andrew. You can work with her. Nope, All you have to do is try to factor. The directions are try to factor. If you have an answer, just hold it up. You may move on to number 2. You may move on to number 2. You may move on to number 2. Pass the marker, pass the whiteboard. 5 and 5. 5 times 5 is 25. Does that make sense? Good. Pass the marker. You guys can move on to number 2. Take your time. It's okay. Get it right. You may move on to number 3. Pass the marker. Oh yeah, sure. You're just factoring. That's it. Just hard. Let me see. Plus 3 plus 5. X plus 3 and x plus 5 is good. You can move on to number 2. Alright, I think most of you have gotten number 1 to be x plus 3 and x plus 5. I think most of the groups have moved on to number 2. Right. Yeah, move on to number 3. Ready? If we check minus 5 is a positive. 7 minus 5 is positive. Number 3? You may move on to number 4. You may move on to number 3. Yes, you may move on to number 4. Pass the marker. You guys have. Then move on to number 3. Yeah, now move on to number 3. Yes, so you guys have 2 extra group members. So, number 5. I just want you to keep going.
What did you say?
I just gave a number 5 to keep you busy.
There we go.
Yes. Now what's the snazzy way to All right, group 6, hands down. But keep going. See if you can finish to the end also. I want you guys to get your 6th problem. You already won. To make up one more problem for your group to do. Make up one more problem. Yes. Try to go to number 5.
Wait, what? We're done.
Try to go to number 5. I'm just keeping you busy, but they already won. Yeah, good job. Good job. We guys have it. Yes. Number 4. Finish it by the thumb. Good job. Yes. Try to go to number 9.
Yeah, we did.
Yeah, you got it.
The one?
I don't have enough for today, but I'll get. Remember, I'll bring 6 of my wickers. But maybe you guys all did such a great job that I might just need to redo this for all of you. Hold. Alright, I'll take the whiteboards back so I can read them. Even though not all of you finished first, we got a lot of good factoring done. We'll see if you guys get your donut holes for yourselves tomorrow. Bye guys. Give me whiteboards on the way up, whoever has them. I'll take markers. I'll take whiteboards. I'll take tissue.